All right, so the Mercedes S65 saga continues. Last time we had our sights set on pushing those upgraded turbos to their full potential, but like any good build, things didn't go exactly as planned. In fact, we had full intentions of showcasing the entirety of the build in one video, but the beast wasn't making the boost we expected. And when a V12 twin turbo underperforms, you know something's definitely off. In today's video, we're pulling back the covers to reveal the real issue, and trust me, it's not as simple as tightening a few bolts. Well, kind of, but the troubleshooting, the adjustments, and why sometimes you've got to go back to the drawing board. What's the most frustrating part about building the ultimate performance mega machine? It's not the hours of tuning or the late night energy drink filled brainstorming sessions. It's when you think you've crossed the finish line only to realize the race just got longer. We thought we were done, but this build is still throwing us curveballs. We're not finished yet, but we're definitely getting closer to unlocking the full potential of this luxury powerhouse. Fast forward 3 months and we're back to dig deeper. So what went wrong? Spoiler, it's only the beginning. But before we jump in, I want to know, what's the biggest challenge you've faced in a performance build? Drop your thoughts in the comments, and while you're at it, hit that like button, subscribe, so that way you don't miss the next chapter of this saga. In the last video, we took a close look at the 2016 S65 AMG, a luxury powerhouse with a V12 engine that's capable of obliterating the competition, all while keeping that Mercedes signature luxury. This build has been a long time coming, with mods aimed at taking this car beyond the insane 630 horsepower the AMG engineers had originally conceived. If you're following along, you've already seen some major upgrades, like the 3.5-inch exhaust system designed to make it roar like a Pagani, the turbocharger upgrades that could push us close to 900 horsepower, and an AC interchiller that ensures we're keeping everything cool when we're running at full boost. We also touched on some common issues with the S65, including misfire, ignition coil issues, and those pesky oil leaks that love to show up when you start pushing power. We swapped the stock turbos for some serious hybrids for an NM turbo, and we're ready to see the real numbers. The goal was to beat a dyno run from a Rentec S65 AMG coupe, which peaked around 700 horsepower. But here's the twist. Things didn't go as planned. Instead of hitting the numbers we were expecting, we hit a disappointing 422 wheel horsepower on the first dyno run. Yeah, you heard that right, 422. We were expecting more, especially after all the upgrades, and needless to say, we're not settling for that. What happened? Was it a tuning issue, something off with the turbo setup? Some of you dropped your thoughts in the comments, and we listened and started from scratch. We've got a big problem on our hands, and after all this work, this car isn't finished yet. So we're picking up right where we left off, digging into exactly why the numbers were so low and figuring out what we need to do to set things straight. Now, of course, you guys had plenty of ideas in the comments about what we should check. So let's go over a few of those. Could it be a damaged map sensor cutting boost without triggering a check engine light? Have you checked the boost pressure switch and fuel pressure under boost? Could be leaning out. Are the wastegate springs matched to the new turbos? It looks like the torque management is cutting power. Could the aftermarket turbos be choking the exhaust like Alex's issue on his CL65? Is the intake airflow struggling? Maybe it's affecting boost. Is it in dyno mode? Have you guys checked the exhaust pressures? Bigger turbos and exhausts might need an anti-lag setup to spool faster. Then we had more than a few questions on boost control duty cycle. So obviously we had a lot of people suggesting to check the wastegate actuators, vacuum lines, and even boost leaks. All great suggestions, and that's kind of what was on the top of my list too. We didn't want to jump straight to the conclusion though. If you start messing with the wastegate adjustment, it's like opening a Pandora's box. And as professionals, we've been down that road before, and it's not pretty. So what do you do when you're stuck like this? Well, you start testing. Smoke testing, vacuum testing, anything to pinpoint where things could be going wrong. And we did just that. And right from the start, we knew something wasn't right, but nailing down exactly what, that's another story, especially since we didn't want to remove this robustly strapped Super Saloon from our Dyno Dynamics dyno. All right, so when we last left off, we were trying to figure out exactly why this thing wasn't really making boost. Some boost, but not really near its target. And I'm pretty sure it's supposed to be substantially higher than 7 PSI. So anytime we take something apart and we've had this engine out, we always have to revert back to what did we do wrong. You know, this isn't something that I'm going to instantly put on the turbos or how it was put in there. We got to look back and think, there's a lot of lines, there's a lot of connections, there's a lot of things that you could potentially leave a little bit off that might cause this sort of issue. Now, it doesn't look like a loss of boost, but it potentially could be. So first and foremost, lowest hanging fruit is we're going to do a smoke test, which is going to see if there are any loose connections, anything that we're missing, vacuum lines off. Maybe something's not connected down by the wastegates. Maybe there's a hole in one of the wastegates. We don't know. So smoke test is going to help us kind of figure that out. Basically, you'll see different versions of this, but what it is, it's a pressurized machine that uses a fluid that it vaporizes, inserts it into high pressure into the engine. In this case, we're going in through the intake route. But you always want a little alleviation before you start, and this is the big thing where a lot of people can get smoke tests wrong, is that if you're pushing the pressurized air into the system and you don't have somewhere for it to escape, that smoke is just going to sit in one spot and not come back out the other side. You want to make sure you open something else up so that way the smoke can fully go through the system. It's smoking out of whatever orifice you opened up. Then you cap it back off and you can start your test. If you start the test without doing that, again, you're just pressurizing the system and not allowing the smoke to go through. You're never going to see your leak. So I'm going to start this up. Now, I think this has a pretty good crankcase connection. I might be wrong, but that's an easy place for us to see. What we want to see is a bunch of smoke coming out of there, and then I'll cap it off, and we'll see if we've got any leaks. Now I see a few small boost leaks on some of the intake piping, but nothing that would contribute to a major boost leak. So we're probably going to move on to the next step, which is smoke testing the vacuum line system and the boost control system, just to try to see if we see any leaks in there. Sometimes the air doesn't get all the way up through there, so we'll double check just to make sure we don't have a line off, something we're missing that's not part of the system, although it should have shown up from doing this test. But sometimes the solenoid valves are closed, so you don't get a full picture of what actually is going on. So we'll pull off some lines and try to see from there. Now we're not really seeing too much leaking as far as the boost system goes. However, we did hear a little noise because it is putting pressure in there from the wastegate system. So we know that pressure is getting in there, they're moving, but it sounded a little funny. So we're going to check the wastegate system now. We're going to apply actual boost that it would be seeing. So we're going to try to see if we can see the rails and when they move, when they crack, and when they're fully open side to side. Now it's a little tight in here and it might be difficult, but I think looking down inside of here, we can see the wastegate arm, and we're going to try to see if we can show you that. It might be a little difficult, but you can see a sliver of it. And what we're looking for is, as we apply boost, smooth operation of those arms that we'll try to point out here in a second. All right, so I'm seeing like a crack pressure. That thing gets moving. It's like maybe 5-6 PSI when this thing starts moving, but
yeah,
I don't know, like this one doesn't seem like it's pushing against anything. It just kind of keeps consistently moving and almost doesn't stop. But that side's weird too, because it seems like it's like a lot harder to get cracked, and then it stops.
It also moves like in segments. Like it moves a little bit. You keep putting pressure, it moves a little bit more. Like it's not linear once it starts moving.
I'm super afraid, and you know this as well, of touching wastegates when they're sent from a manufacturer because they're so dialed in and sensitive. It's not like the old days where you used to be able to crank up your wastegate to try to get a little bit more boost out of it. They're very calibrated to the vehicle, and a lot of these late modern cars are very sensitive. You can trigger faults right out of the box having them wrong. However, this is the aftermarket. We deal in aftermarket, and I'd say this is like the fourth or fifth time we've seen problems with aftermarket turbos out of the box where they're not set up correctly, and we were relying on the manufacturer. And you think I would have learned my lesson the first time. So it's a tricky situation. I think going forward, and I don't know what we're going to find down there because I don't even know if we can get to those rods. I don't even know if it's going to be easy. We got to put this thing up in the air and try to see if we can get back there because it's so tight to the block.
I remember when we had the engine down on the floor changing out the turbos, I don't feel like there was too much in the way, at least back here on the backside of the turbo where the wastegate arm is. So
do you think you can see up in there?
If we just get it up on a lift and get the shields off, I think we could probably grab the back end of it and adjust it if we have to.
Something's going on. I mean, the movement side to side's wrong. I don't know which side's right. But I do know that if they're not synced up and moving at the same crack pressure and the same fully open pressure, that you're going to have one side either forcing through the other side or it just not building boost at all, it completely bleeding off. So that's got to be right.
I think this side's definitely wrong. Like you give it like 2 or 3 more PSI and then it'll move some more.
Well, that side's like stopping, but this side just seems like it wants to keep going infinitely. Like it doesn't ever seem to stop. Like you had 26 or 27 PSI up in there before it stopped moving. And I don't know if the car is set to that. I mean, that could be a pressure that it's targeting, but I guess we'll have to find out. That being said, the only thing we could do really now is try to see what we can see underneath and hope that we can get in there and not have to take the turbos down. That would be a disaster for us and just the customer's expectations. And it's not something I really want to admit to having to go back and do, but this is just, I guess, another day in the shop. So we had to get the car off the dyno, no ifs, ands, or buts about it, and it was extremely obvious what was going on once we put it up on the lift. After going through all the tests, we finally found a smoking gun, a missing nut on the driver's side turbo wastegate. Simple enough, right? We thought so too. Now, we didn't touch the turbo wastegates during install. Had we might have seen the nut loose because it was definitely on there when we started.
So on the dyno, we're dealing with no boost on this S65. Take the undershields off, look at the turbos, and right away, I can see a nut came off the wastegate up there. So it seems like it should be an easy fix. Just put the wastegate back on and the rod back on the wastegate and tighten the nut down. But you can see, I hope this nut didn't move too much because that's controlling the adjustment, and any engine vibration will turn that nut. As you can see, it moves pretty easy. So I'm going to try to match it up to the other side, and we'll retest and see if we get boost back. But it seemed to be on both sides, so I feel like I'm going to have to make an adjustment on this other side too. But I'll get right on it, and let's see what happens. Cut! It's a trick my grandma taught me working on cars. Put a piece of paper in there to hold the nut on your socket. It's stainless steel though, so you can't use a magnet. Damn it, Grandma. Didn't work.
To better explain what we're actually trying to do, I've got one of the old turbos here. And if you're not familiar, this is the wastegate actuator. Now, before when we were testing up top, I was showing you crack pressure versus spring pressure. Crack pressure is the pressure when the arm first starts to move. And as you can see, 0 PSI right now. And as I begin to move this up, the rod starts moving right about 7 PSI. But it continues to move until we reach 14 PSI when the arm stops, which means At 14 PSI, the turbo is then trying to bypass as much as it can to make sure that the turbo doesn't make any more than 14 PSI. The thing that we were worried about is typically these arms are very finely calibrated. So if you go messing with this length, that is going to change how the boost responds. So by preloading it, you could potentially cause the turbo to boost higher, but then that's going to max out where that arm ends up as well. So you could run into issues not only having the boost not be in the right area, but also ending up where you're having the arm bind, maybe even causing damage to the wastegate rod or actuator because it's trying to press out and stopping in position. So typically it's not something we like to mess with when the turbo companies are the ones who are supposed to be kind of setting these things up. But that being said, you still should know kind of how they operate. And a big way in how they operate is the crack pressure versus spring pressure, full open spring pressure. So by knowing those two variables, you can kind of anticipate where it's starting to work in the cycle. So with the crack pressure, you see 7 PSI, which means we're going to get no response. That wastegate's trying to make as much boost in the turbo as possible before 7 PSI. Then after that, it's going to start bleeding stuff off. Now again, that's also controlled by the boost solenoid, which is something else we tested. That's regulated by duty cycle via the engine computer, and that's allowing the boost to actually get to the solenoid, which that's how you actually can create ECU tunes that increase the boost. But mechanically, this is what's doing the work, and the signal that's sent there via the wastegate actuator is how it actually controls boost. So what we're doing is we're putting the nut to about where we think it should be within its cycle. Again, this is very hard to know exactly in comparison. However, I will say it is much easier on old styles like these that are boost pressure opened versus the newer styles where they're vacuum actuated. It uses vacuum to keep it closed via another vacuum reservoir and solenoids. Those systems tend to default into a safer position. However, they're very, very sensitive to changes in the wastegate rod, and even 1 or 2 turns can mess them up, as these older styles are much less sensitive. So we threw the nut back on, adjusted the binding in the passenger side, and got it back on the dyno. And we were confident that we solved the issue. Everything was pointing to this being the problem, and honestly, at this point, we were ready to believe it. So we put it to the test. All right, so I could already tell that felt a lot different. It felt like the torque was building right at the beginning of the run, which it wasn't really doing before. It loaded up, but then it just fell on its face, unlike the last runs before we found the nut. And we've got a way different boost curve. Boost gets as high as 10 PSI at the beginning of the run, and then falls off to 7 PSI at the end of the run, which is kind of opposite of what we had before, where we had continuous boost going up towards the top. Oh man, I was really hoping that we'd be seeing some great numbers right now and this would be done, but I think I know what's going on. And it also means I'm gonna have to pull it back off the dyno. So as you can see, we've got way lower numbers than we even had before, when we essentially had a wastegate that wasn't controlling pressure correctly. And this is shockingly lower, but not shockingly lower in the sense that we are only making 9 PSI all the way through, where before we were making 9 to 10 PSI at the top end of the limit, but the car was still trying to make power down low. The boost was coming on, it just wasn't enough, and it wouldn't peak out towards till the top end of the RPM. I took the manifold pressure also from a source that reads into our dyno. It matches up, so I know at least the car is making what it says it's making, so I don't have a manifold pressure sensor issue. But what I think's going on and what I'm gonna have to do about it is, I think when we put that wastegate nut back on there, we just kind of counted the threads and hoped that putting it back towards the approximate location of the other side would be enough. But I think there's gonna be some adjustment involved. Now, depending on the type of system it is, this could be very in-depth, and it might take some going back and forth, which could be a nightmare scenario because I don't want to pull this thing off the dyno each time I need to make an adjustment. So what I think I'm going to do is call the manufacturer of the turbo and ask them for the proper procedure to set these wastegates. Now, these aren't vacuum actuated in the sense like a modern BMW N54, B58, some of the newer European models. These are traditional old school boost opened via pressure, where it bleeds it off once it reaches its target spring rate for the boost. So that being said, it might be a little easier if that's the case, and this is kind of a little bit more of a simple boost regulation via duty cycle and the solenoid, but I'm not 100% sure. I'm going to have to talk with the manufacturer about that, but I'm also going to have to get this car off the dyno, but that's just how it shakes out sometimes. Before we went down that rabbit hole, we called up NMM Turbo, and they had a recommendation: tighten the wastegate nuts by 10 turns. So I'm not super worried about getting these tight, but we did talk with NMM Turbo, and they really just said, wherever you're at, tighten it up 10 more turns, which is what Keller's going to do here in a second. And hopefully this puts us in a range that works. I don't have to pull this car back down and we do this again. Hopefully we're right on the money and we get to see this car make the power that it really should be making at this point. But sucks that we had to do this twice, but hopefully this is the last time. Now I know what you're thinking. 10 turns on a wastegate nut? Kind of sounds like overkill, but we were willing to try anything at this point. And Keller and I went ahead, made the adjustment, and put the car back on the dyno. I showed you guys on the stock turbos how they respond: 7 PSI, 14 PSI crack pressure, or 7 PSI crack pressure, 14 PSI all the way open, which means this car should be holding 14 PSI. Now, this last run that we had here, where I had the readings hooked up to the dyno, you can see we peaked at 11 and then fell off below 9 here, and it made terrible power for that. This run here was when the issue was going on with one of the wastegate solenoids trying to push through right after we did the turbos. So you can see kind of two completely different power curves, but boost is coming up earlier here, just not at target. And here it's really fighting to make boost at peak, which is probably because that one wastegate wasn't even pushing, it was just being held closed. So it could make some boost, but not enough on the other side. With that said, we've got this dialed down where we feel like there's enough pre-tension on there, and that's the big challenge. Is we were really just given turn it down 10 turns and try again, and we were even given the caveat of, if for some reason you guys can't hit your boost targets, we may have to go with an aftermarket actuator, which honestly isn't really what we want to hear after putting these things in and knowing that it'd be kind of difficult to get those things out while on the car. So I'm really hoping that this works, that we get our 14 PSI. Right now I've got a stock file on there, so that's where we should be targeting. I'm gonna run it, keep my fingers crossed, and hopefully we just see something different with this power delivery, how it comes up here, and that'll allow us to start making the changes that we were supposed to make in that first video. Let's give it a shot. This is good news. Now, I got a lot of squiggly lines here, but let me explain what I'm seeing that's got me so excited. Now, before that 484 run, you remember from the first video, that was kind of our peak run where it was peaking at the very end, and I said this just doesn't look like an S65 torque graph, dyno graph. It just wasn't doing what these cars typically do, which is come up, hold, and then fall off a little bit at the end. Now, keep in mind, this is a stock file, and these cars are rated at 630 horsepower, so us hitting 500 wheel horsepower is pretty much right on. Now, yes, this car has bigger turbos and downpipes, which is why we're probably seeing these numbers, because typically these things will dyno around 470, and this car is untuned, and the boost is at stock level. We're coming up, shooting past 14 a little bit, 15 PSI, and then falling down towards the end. We've got to see if we can control that with the wastegate via the tune. But that being said, this is a very, very good sign. Turns out it's exactly what it needed. The boost is finally hitting the right pressure, and we're making the power this car came with stock. So with the boost pressure fixed, this V12 is back in business. Look at that power curve. Before both these files, the red one being the first one that we had, where one wastegate wasn't even operating and the other one was doing all the work. The second one where we had them both not adjusted correctly, but it wasn't making the top power. And this one where it just comes up. Pretty much we're at full boost at 3,700. And there is a 20 to 30 horsepower difference from 4,000 on where it just holds it. So this is actually better. Typically we see these things fall off well before 5,500, which is kind of holding peak power till that point. So super promising. I think this means I can actually start tuning it and we can start going after some numbers. And like I said, hopefully there's going to be some big power once we dial in those turbos, once we dial in the downpipes, just for all the modifications we did in the excess cooling systems that we've got. So now I can finally get to work. The result, a different power curve and boost, but still not the number we wanted. We knew the car was underperforming, and our initial optimism started to fade. This is where it started getting frustrating. I'm thinking to myself, if this adjustment doesn't work, what are we missing? We even debated taking the car apart again, which is the last thing we wanted to do. So when we pulled this car in the dyno all those weeks ago, after finding the wastegate problem and fixing it, we assumed that we were maybe a file or 2 or 3 renditions away from having a respectable dyno number to finish this car off. And since then, it's been 3 weeks with 14 renditions of the file, maybe about 50 or 60 dyno runs. And we are still scratching our heads as to why we can't get the boost level to peak over 16 PSI, 15 PSI, I should say. Right about 3,800, we peak at our peak boost, which is between 14. I've seen it get as high as 15, but it tapers off in the same fashion. Now, like I was saying a second ago, we initially thought that it was in the file, that somewhere, some way, that this being a new processor, the Bosch ME 17.8.7, something like that, it being a new processor that's used in a surprisingly large amount of vehicles, that we just didn't have the information. While the processor is used in a lot of vehicles, it's not used in this combination. So finding someone with the right information to be able to move these tables, it could just be more difficult. So I've contacted my typical channels, going through trying to find out who has good information to be able to make power on these cars. And that led me to a few spots where we're logging. And initially, it was because we weren't sending the signal correctly. We weren't accessing the correct maps for the actual boost parameters to control the wastegate duty cycle. But since then, we've found those areas And even though we're changing them, we're not seeing any difference in boost. We've gone from a 66% duty cycle to an 80% duty cycle and no visible changes in boost. Now, could there be something behind? All we're watching is the request in the ECU, the request to it. I haven't hooked up a meter to see if I'm actually at an 80% duty cycle. I may need to do that, but there was a tip that I was told from Knight's Turbo about them not being sure of the wastegates, if it could handle the boost. And I wasn't quite sure what they meant by that. Apparently, they haven't really messed around with these wastegates on these turbos in this car, in this configuration. So their guess was as good as mine in how this would respond. So what that got me thinking is, do we possibly have a situation where we're possibly pushing the wastegates open, it not holding the pressure inside of the turbo, and it's bleeding boost off? The graph doesn't appear that way. However, I have seen weirder, different things on different cars, and at any time we're starting to exhaust ourselves electronically, and especially when it comes to tuning, always check and recheck your mechanical. And unfortunately, that's what we're gonna have to do. As much as I don't want to, and as much as I want this thing to be done and finished and move on to a different project, I'm gonna pull this thing back off. And what we're probably gonna do is we're gonna tighten the wastegates down a little bit more, and we're gonna see if it makes a difference. If it doesn't make a difference, it's possible that we're still dealing with a wastegate issue actuator, that maybe the pressure inside of the manifold is just too high, and we need to go with a whole different aftermarket wastegate option. But hopefully it doesn't. Hopefully I'm gonna see some sort of bounce after messing with this, and something that'll give us a little bit more control via the ECU side. But it's also possible that we just don't have the information for this car, and we've got to completely figure something else out. So with that being said, this is just another challenge that we typically see when we're trying to tune cars that really don't have big aftermarket support. Run after run after run after run. I mean, we've got over 69 dyno runs, and I would say probably about 12 files sweeping between a OE duty cycle of 45%-ish all the way up to about 80%. And I've got the big ones here. This low boost number here is that stock run at OE, and you can see we're somewhere around 11 PSI. Now it's hard to say because this is an external pickup on the dyno, so the engine computer could be picking up a touch more, but this is showing 11 PSI when we loaded the stock file on, and it showed 45% duty cycle. And up here when we were hitting the 15s, some of these were basically around 80% duty cycle, but there didn't really seem to be a big difference once we crossed over that 60 mark. That stopped the boost that would come through, and we couldn't figure out exactly what was going on. Now, for a while, we thought it was the tune and figured there was something still in there, but we've basically confirmed that there's something else going on here, and that got us thinking there's got to be something going on with the wastegates. Are we seeing the turbos now over pressurizing the hot side and possibly forcing those wastegates open during the run? Typically you see more of a wave when that happens, but it's very possible that the pressure is just building to the point that overcomes the spring and even the boost pressure on the other side, and it just cannot keep up in order to deliver the boost we want. We should be hitting about 20 PSI or higher, and no matter what we do, we're just not. So after pulling our hair out and basically triple checking every connection, it was painfully clear the wastegates on the shiny new turbos have to come out, and they're just not cutting it. So I called up Night-Turbo. They agreed kind of what we were seeing, and they want to check out the wastegates to see if they can come up with a solution. But it's a big setback. But if it was easy, everyone would have already done this. So it's kind of one of those things where we're just going to have to bite the bullet and take care of it. So what's the takeaway? Building a car like this is a roller coaster, highs, lows, and plenty of loops. But that's what makes it worth it. Luxury and performance doesn't come easy, but when it's done right, the results are nothing short of magic. Got thoughts on this build so far? Drop them in the comments. I'm curious to hear your theories on how many more episodes this saga might need. Don't forget to like, subscribe, and hit that bell icon so you're the first to know when the next chapter drops. Until then, stay fast, stay loud, and remember, perfection takes time. Catch you next time.